All right, the fundamental counting principle. So, the fundamental counting principle states that if you pick one item from a group of m items and a second from a group of n items, then the total number of two-item choices is m times n ways. In general, the number of ways in which a series of successive things can occur is found by multiplying the number of ways in which each of those things can occur. So we've got two examples for this section. The first one's pretty straightforward, so we'll start with it. So a restaurant offers 4 appetizers and 12 main courses, and how many ways can a person order a 2-course meal? So in this section, and when we talk about permutations, I'm going to be calling these types of problems blank problems. And what I mean by that is I can solve these by using blanks. All right, so what I'll do is I look at the things going on. We have our appetizers, our main courses. I'm going to create a blank to represent my appetizers and a blank to represent my main course. And that will be the numbers that we multiply together. So we have 4 appetizers, we have 12 main courses. You should be able to do that without a calculator, but if you need to use a calculator, especially on a test to be sure, just type it in the calculator. Let's look at the next one. So this first example is an example where there's no restrictions on the items. In the homework, the ones that are going to give you trouble will be more like example 2, where there are some restrictions on some of the blanks. So, how many different arrangements of 5 letters, okay, so that's our thing, 5 letters, can be formed if the first letter must be a W or a K? Okay. So forgive the coffee stain right there. So again, I can treat this as a blank problem. I'm going to treat all of these in this section as a blank problem, as well as some of them in the next section. All right. So I think I'll put my first blank here so I don't run off the page. All right. So in the rules, it says the first one has to be a W or a K. But there's no restrictions on the rest of these. So the rest of these can be A to Z. So I'll just remind myself. So we have 5 letters, 1, 2, 3, 4, 5. The first one has to be a W or a K. There's only 2 ways to do that. The next one can be anything between A to Z. If you count up all the letters in our alphabet, that's 26. So each of these blanks will be a 26. If we multiply these together, let me just give you the answer first and I'll show you something else. So 2 times 26 times 26 times 26, that's 3. Fourth one, you get 913,952 ways. Now, as I was working through that, you could tell that I was counting the number of 26s. So in this problem, there's only 4 26s we're multiplying together. But in some, you may have 10 26s or 10 of some number you're multiplying. So if you have the same number you're multiplying a few times, the way I would do this is type it in like this. So 2 times 26 times 26. Oops. 2 times 26 times 26 times 26 times 26 is equal to 2 times 26 to the 4th. So the way we calculate or do that on the calculator is I'm going to type it in the following way. I'll do 2 not caret, we're going to multiply first, so let's just start over. 2 times 26 caret 4. All right, so 2 times, now the parentheses here may be optional, but anytime I'm doing a demonstration or if I was taking a test, I would probably be careful with parentheses. I want the calculator to do 26 to the 4th first. I don't want it to multiply the 2 and the 26 together and then raise that to the 4th. That's wrong. So the calculator might know the correct thing to do here, but if it doesn't, just do 26 to the 4th, parentheses, times 2, and we also got our 913952. So those are the only examples we're going to do in this section, but you're going to notice in the homework, a lot of the ones that are tricky will be of this form, where there's some restriction on some of the blanks in the problem.